Greetings to you, wherever you are watching me from. You are welcome to my page once again. If today is your first time of seeing my page, please ensure you click the like button, click the follow button, click the share button. Just anything that will make you to always get a notification each time I make a post. Just do that. Then you will enjoy every bit of my teachings. Now, let's look at this simple chemistry problem from the past questions. Determine the number of unpaired electrons in 1s2, 2s2, 2p6, 3s2, and 3p5. So this is electronic configuration of a certain atom. So for us to determine the number of unpaired electrons there, anytime you are required to determine the number of unpaired electrons, your area of interest is the very last sub-level. The very last sub-level. And you have to know that each of these sub-levels contain a certain number of orbits. The S sub-level has one orbit or one orbital. The P sub-level has three orbitals. We have this sub-level has 5 orbitals. Then lastly, F sub-level has 7 orbitals. An orbital is a region, the region in an atom where there is what? Probability of what? Locating or finding electrons. The region in an atom where there is a possibility of what? Finding electrons. And the maximum number of electrons an orbital can hold is 2. The maximum number of electrons an orbital can hold is what? 2. So to represent this, for the S, we have just one orbital, and it can hold maximum number of 2 electrons, which are arranged spinning vertically upwards and vertically downwards according to Hund's rule of maximum multiplicity. So in the spin, they spin in opposite direction. Then in the p orbital, we can represent showing the p sublevel. We have 3 orbitals. Each orbital can hold maximum number of what? 2 electrons. Then we have the D has 5 orbitals, each holding maximum number of what? Maximum number of what? 10. Then the F can be 1, 2, 3, 4, 5, 6. You have 7, each holding 2, 2. Maximum of 2 each. So from this now we can see that the maximum number of electrons an s orbital can accommodate is 2, and that is why in the electronic configuration the highest number s can take is 2, unless maybe the number of electrons remaining that's supposed to fall on that s depending on the atom is no longer up to 2. Can represent, write the 1 there. Maximum number of electrons p can hold is 6. Maximum is 6. So it can be lower if p falls, if in the electronic configuration that the last sub-level is p and the number of electrons is no longer up to 6. You can, just like we have 5 here, meaning just 5 left. it can represent. Then the maximum D can hold is what? 10, and the maximum F can hold is what? 14. So in order to answer this our problem, we look at the last shell in our question, or the last sublevel, which is P. And we have already known that P has 3 orbitals, with each orbital accommodating to 2 electrons. But remember, according to Hund's rule of maximum multiplicity, we have to add the electrons singly. Hund's rule say when electrons are entered in degenerate orbital, that Hund's rule. When electrons, or when filling the degenerate orbitals are orbitals that have the same amount of energy. Like all these now are degenerate orbital because they belong to the same sub energy level, so they have equal energy. So the electrons has to be entered 1 1. So we have to enter the 5 electrons 1 1. Then you pair up. That completes it 5. Leaving what? The last one unpaired. So each 2 electrons represent a pair. So this is pair, this is pair, then this is what? Unpaired. So we have 1 unpaired what? Electrons. 1 unpaired electron. Now what happens if the question changes? If the question asks you to calculate the number of paired, that is the opposite now, the number of paired electrons, what do we do? You see, we check, this is S, and it contains just 1 orbital, 2 electrons, that is a pair. So in every S with complete number of 2 electrons, it just represents 1 pair. So this is 1 pair. Remember, this has to be completely entered before this. This is 1 pair, another 1 pair here, that is 2 pairs. Now in this P here, there are 3 pairs. 1, 2, 3. So 1 plus 1 plus 3 here is 5. Then plus 2 here, 6. Then plus another 2 on this one, 2 paired, because it's unpaired. So that makes a total of what? 8 unpaired electrons. I trust you enjoyed the video. Please don't forget to click on the like button, share with your friends, don't be greedy, and ensure you follow me to always get what? An update. If there's any topic you want me to make an in-depth teaching on, do well to drop it on the comment section. I promise you I will make out my time to give you the best. Thank you and God bless you. See you soon.